Today we're going to be talking about section 14.2, which is about solving rational equations. Just as a reminder here, this what we're doing in chapter 14 is normally review from Algebra 2. Now I know that most of us didn't see these topics in Algebra 2, so I'm going to try to go through this slowly and quite carefully for us, just so that we have a good foundation here moving forward. And if you are planning on doing like an ACT here in the near future, these are good ACT topics, all of these next things that we're doing. I would be surprised that if you did not see something like remarkably similar in your math ACTs. Okay? All right, so this topic we're talking about today is about solving rational equations. Remind me again, what is a rational function? All right, that's what we've been talking about. We've been these rational functions. What does it mean to be a rational function? What does that look like? Anybody remember? Can tell me in their own words, even if you don't know like the technical definition, that's okay. So a rational function is a fraction where you have a polynomial on top and a polynomial on bottom. Do we see any rational functions in the equation x plus 3 over x equals 4? Megan, you shook your head. I'm going to call on you now. I know. It's okay. Where is the rational function at? Yeah, that's correct. Now, technically, the x and the 4 are also polynomials, or also rational functions, because you could think of them as over 1, and 1 is technically a polynomial, but like we usually don't worry about that. Is everybody kind of okay with that idea? So when we talk about a rational equation, we just mean an equation that involves one or more rational functions. Everybody's okay with that? So this one right here is a rational equation because we have the one rational function, 3 over x. Sound good? Okay. Our solving method that we're going to be using to deal with these things is called clearing fractions. So the idea here is to clear fractions. We're going to multiply both sides of our equation by something so that when we do that, all the denominators cancel out. Okay? So let's take a look at our equation. X plus 3 over x equals 4. The only denominator we have to worry about is this x. Everybody agree with that? What do I need to multiply 3 over x by so that the x in the denominator cancels out? Well, I don't want to use the reciprocal because that'll make fractions in the other places. I don't want to use a fraction when I multiply both sides. I just want to use a thing. Right? I want 3 over x times something is going to give me just the 3 left. What is that something got to be? Let's do it with no x's. What if I just have 1 over x, or 1 over 2 times something has to equal 1? What's that something have to be? 1/2 times something equals 1. What is the something? Anybody see it? What do we have to multiply 1/2 by to get 1? 2. Great. Where'd you get the 2 from? So what are we going to multiply 3 over x by? X, right? Same pattern. So what should we multiply both sides of this equation by? X. So we'll distribute the x. Is everybody okay? So far, so good? If I go too fast or I do something you don't understand, speak up. We can elaborate or re-explain or just slow down. So we have x squared plus 3x over x equals 4x. What do you notice about the fraction here? It can cancel. What can cancel? The x. Now, what kind of an equation do you notice we're left with? X squared plus 3 equals 4x. What kind of an equation is that? You should be able to answer this. We've done it this year and last year. So 2 acceptable answers. One starts with P, the other starts with Q. Polynomial is the P one, yup. Quadratic would be the Q one. The quadratic is the more specific answer. That's the better one that we would have wanted to use. How did you know this was quadratic, Ava? You guessed. If you look at the exponents, the biggest exponent is 2. That's a quadratic, a polynomial with exponent 2. Everybody's okay? To solve a quadratic equation, what's the first thing we have to do? It's got to what? Equal 0. Does it equal 0 right now? No. How are we going to make it equal 0? We'll just subtract the 4x from both sides. Everybody's okay there? Now it equals 0. How do we solve a quadratic equation? You could factor it, or what's the other method? Quadratic formula. Either is okay. In this case, anyways. Let's choose factoring because the leading coefficient is 1. So if it does factor, it should be pretty easy to do. To factor this, we need to find 2 things that multiply to give us positive 3 and add to give us negative 4. Negative 3 and negative 1 are correct. So I can then set those factors equal to 0 and solve. Is everybody okay there? Here's the catch. We're not done. Why not? What equation did we actually solve for? We solve for this. That's a quadratic, right? What's the domain of the quadratic? Always all real numbers. What equation are we trying to solve for? This rational equation. The domain for a rational equation typically is not all real numbers. We could have vertical asymptotes or removable discontinuities. They're causing a break in the domain. So it's possible that the answers we got when we solved the polynomial could be at the location of a vertical asymptote or a removable discontinuity or some other weird thing and not actually be a solution that works. So what do we have to do? We have to check these answers. So if I check x equals 3, I'm going to go back to the original equation, and everywhere where there's an x, I plug in a 3. 3 plus 3 over 3 equals 4. Well, yeah, because 3 over 3 is 1, and 3 plus 1 is 4. We'll do the same thing with the 1. Yeah, that works as well, right? 3 over 1 is 3. 1 plus 3 is 4. So each of these are solutions. What do you guys think? So far, so good? Not too bad, right? Let's do another example. Okay, so the first thing I'd want to do is clear fractions. Who can tell me what I need to multiply both sides of this equation by to get rid of the fractions? Who wants to posit a guess? It's okay to be wrong. That's correct. X plus 1 is the answer. We have just the one fraction. So whatever the denominators for that fraction, that'll be what we need to multiply both sides by. Everybody okay? So far, so good. What do you notice about the fraction? It cancels. So I'll distribute my x through. What am I left with? A quadratic. How do you want to solve this quadratic? What are the two methods we use? Factoring of the quadratic formula. Excellent. Which one would you prefer to use here? I'd at least try factoring, since the leading coefficient is 1. So are there two numbers that multiply to give us -6 and add to give us 1? 3 and -2. So we can set each of those factors now equal to 0 and solve. Everybody's okay there? What do we still need to do, though? Check. You want ready to see the shortcut for the check? There's really only one thing I need to check. Remember, what I'm really checking for is to make sure that these answers aren't a removable discontinuity or a vertical asymptote, right? When do those things occur? Think back to last section. Those only occur when the numerator denominator. Denominator is equal to 0. So all I really need to do is take this answer, go back here, and if I plug -3 in for x, does that give me a 0 denominator? -3 plus 1, is that 0? Is it? No! No. So that one's okay. Now let's take the next one. X equals 2. Is 2 plus 1 equal to 0? No! So that answer's okay also. So that's all there is to that one. Are we okay so far? So up until this point, it's been pretty easy because there's only been one fraction in our equation, right? Let's look at another example where, oh boy, that's not the case. So how many rational functions do you see in this one? 3. There's 3 fractions with x's in the denominators, right? Okay, so I want to multiply both sides of this equation by something that's going to cancel out all of the denominators. And really, I want to pick the least thing to multiply both sides by to cancel out the denominators. What should I do before I start looking for that thing? There's something that I should do that would help me enormously. What should I do before I try to figure out what I need to multiply both sides of this equation by? Something kind of obvious. Look at the fractions involved. One of the fractions looks a little bit different than the others. Which one is that? The one on the right. Specifically that part of it. What can you do with that? Factor. Great. Let's factor that. What multiplies to give me 3 and adds to give me -4? -3 and -1. So I'm going to replace this down here with the factored form. So what am I going to need to multiply both sides to cancel out all of these fractions? What's one thing it has to include? Well, if I want to cancel out the denominator from this fraction, what has to be in there? X minus 1. If I want to cancel out that fraction, what's got to be in there? If I want to cancel out this fraction, what has to be in there? Both of x minus 1 and x minus 3. Everybody agree with that? So what am I going to multiply both sides by? Just x minus 1 times x minus 3. So distribute things through. Am I going okay here, folks? Is this too fast? Trying to be very deliberate with what we're doing. Talk through all the steps. Really kind of explain what I'm thinking. Now, what should we do? Cancel. So I see the first fraction, x minus 1, can cancel. The second fraction, x minus 3, can cancel. And in the third fraction, both the x minus 1 and the x minus 3 can cancel. So I'm left then with 2x times x minus 3. And I'm left with an x minus 1. And that equals 2. It's okay. So we'll distribute the 2x through. Oh my goodness. 6. Sorry. Then let's combine some like terms. And I'm going to subtract the 2 over, so it's equal to 0. Everybody okay? What are we left with? Quadratic equation. How do you want to solve this? We said we could use factoring or the quadratic formula. Which one would you do in this case? I know which one I would do. I would do the quadratic formula here. Why would I use the quadratic formula in this case as opposed to the previous ones? Yeah, that leading coefficient isn't 1. So if I try to factor this, that's going to be kind of that long, tedious method. I just assume avoid that. So the quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2 times a. So 25 plus 24 over 4. 25 plus 24 is 49, and the square root of 49 is 7. So if I add 5 and 7, I get 12, and 12 over 4 is 3. If I subtract, that's going to give me negative 2 over 4, or just negative 1/2. Everybody okay here? Am I done? Are those my two answers? Nope. What do we still need to do? Gotta check. So I'm going to take my 3, go back to the original. If I plug 3 in here, does that give a 0 denominator? 3 minus 1, is that 0? No. If I plug it in here, do I get a 0 denominator? Yes, I do. As well as if I plugged it into that denominator, right? So what does that tell us? That solution of 3 does not work. We have a phrase in this sort of to describe this sort of situation. We call that an extraneous solution. Now, if we go and do the same thing for the -1/2, if I plug -1/2 here, -1/2 minus 1, is that 0? No. -1/2 minus 3, is that 0? No. And if I do it again here, again, both not 0. So that one is perfectly fine because it doesn't give me a 0 denominator at any point. So far, so good. Okay. Let's do another. So here I have 2.5 over x minus 3 plus 0.5 over x minus 1 equals x squared over x squared minus 4x plus 3. What's the first thing I should do before trying to figure out what I need to multiply both sides by? Thanks. Great, is factor all the denominators, specifically x squared minus 4x plus 3. What does that one factor to? -3 and -1. Why did I write it that way, dum-dum? What should I write that as? The factored form, right? Why bother factoring it if you're not going to use it? Okay. What should I multiply both sides by? X minus 3 times x minus 1. Very good. So we'll distribute that through. Okay, multiplied it all out. What should I do next? Do my reducing. Everybody's happy with that? We'll then distribute those coefficients through. Then we'll combine like terms and move everything over to the other side. So 2.5x plus 0.5x is 3x. So I'll subtract that over to the other side. Negative 2.5 minus, and then negative 1.5 is negative 4. We'll add that over to the other side. Is everybody okay? I put everything on the right-hand side so that my x would be positive, or my x squared would be positive. Makes the factoring easier that way. Okay. How do you want to solve x squared minus 3x plus 4 is equal to 0? Okay. What multiplies to give me positive 4 and adds to give me negative 3? Ooh, nothing, right? What happens if if we can't factor it? Got to use the quadratic formula. So this one looked like a nice candidate for factoring, but we know that factoring doesn't have to work every single time, and that's okay. Sometimes we just need to use the quadratic formula. That's what's happening in this case. So negative 3 squared is 9. 4 times 1 times 4 is 16. 9 minus 16 is negative 7. And what's the square root of negative 7? Square root of negative 7. Well, it's I square root 7, yes. Yeah, the point was we needed the I in there. Excellent. So what kind of answer did we get here? When it has an I in it? It's called an imaginary solution, right? Because that was imaginary, it means that there was no real solution. So are there actually any solutions to this? Not real numbered solutions. It's kind of like a no solution answer, right? I'd be pretty surprised if something like that didn't pop up on an ACT question. It's really helpful on a multiple choice to have like no real solutions as a possibility, because you can really write some tricky multiple choice questions if you have those kind of options all over the place. All right. I got one more example for you, but this one's a story problem. Bill wants to fence in a rectangular pasture. The pasture must be 500 square feet. What is the smallest amount of fencing that Bill will need? Well, I like to start a problem like this by drawing a picture. So the picture I'll be drawing in this case would be a rectangle. And I'm going to call the length x and the width y. Everybody okay with that? With the picture I've drawn? I'm then told the pasture must be 500 square feet. What is that describing to us? "500 square feet." What is that telling us about? The area. Excellent. And again, because it was a squared unit, you know it was talking about an area. How do you calculate the area for a rectangle? Who remembers how to do that? It's almost a pre-algebra question. Area of a rectangle, go. Length times width, yep. Or in this case, we called those dimensions x and y. So we can say 500 is equal to x times y. So far, so good? Okay. The next part asks then, what is the smallest amount of rectangular fencing Bill will need? What is the amount of fencing? That's the perimeter, right? Good. And how do I calculate the perimeter for a rectangle? What is the perimeter? What is that like describing? What is the perimeter describing? Just like the distance around, right? Yeah, that's right, Archland. So we'd have like x plus y plus x plus y, or just 2x plus 2y. Everybody's okay there? And then we're asked for the smallest amount of that. So what we're really looking for is like the minimum value that P can have. Everybody's okay? So far, so good? Now, what's the problem with our equation for P? Will I be able to calculate a minimum with it the way it's written? No, I can't, because how many variables do I have in that equation? I have 3. P, x, and y. That's one variable too many. I need to find a way to eliminate either the x or the y from that equation. Well, I'm going to choose to eliminate the y. And the way I'm going to do that is I'm going to use my equation for area to get y by itself. Is everybody okay with what I did there? Yes, Pat? Sure. Okay. At this point, I've done everything I need setup-wise. I'm just going to type this into my calculator and use my calculator to find the minimum. So I'm just going to type in my equation exactly like it looks on my sheet of paper. I'm going to set my window. X is representing a distance. So I'm going to set the x minimum at 0. And the x maximum, I don't know, I just picked 50. That seems like plenty. Like 50 is one of the side lengths of the pen. And the y is representing perimeter again. So the minimum value, or my y min I'll pick is 0, because again, perimeter is a length that needs to be positive. And the maximum, I don't know, I just picked like 200. Figured that would be more than enough to find the biggest. So I'm going to hit graph. So what I'm looking at is like right around here looks like the minimum, right? So to find that point exactly, I'm going to press second and then the trace button. I'm going to select the minimum command. And now it's going to ask me 3 questions. It's going to ask me for left bound or right bound and a guess. So I'm going to start by moving my cursor somewhere left of where I think that minimum is. That looks good. I'll press enter there. Then it says a right bound. So I'm going to move my cursor somewhere to the right of where I think that minimum is. So just somewhere past that little flat looking section. That looks good. Press enter. Guess doesn't really matter as long as it's in between the two. So it tells me then 2236, comma 8944. So this was my value for x, and this is my value for p. So my p is 89.44 feet. It's the least amount of fencing that I can use to build my rectangular pen that contains 500 square feet of area. What do you guys think? That's it for section 2. At this point, you guys should be able to do, what, 25 to 34? But we're done so early. Let's do a couple of these problems together. What do you say? I'll pick a couple of problems from the homework here. We'll give you guys some minutes to work on them. We'll call on some random people to help us do them. And then go about our day. Notice what kind of problems am I picking here. Look at the numbers. What am I picking, guys? Evens. Yeah, Natalia? Of course, sure, go ahead. Why do you suppose I picked the evens? Yeah, I'm helping you out, guys. All right, so we're going to take a couple minutes, let you guys try some of these. Then I'll call on some people to help me kind of step our way through these. It'll be random, the people that I'm calling on. So everybody needs to try to do these. So take out a separate sheet of paper or your notebook or your tablet or the back of a napkin or the side of your water bottle or the spare shirt you have for gym class or the back of your hand. Whatever you do like to do your homework on. And then give us a shot. We'll take 5 minutes or so for the first one. We'll do that one or go through that one together. I'll call on random people to help me with my steps. So every time I do a step, I'll call on a different person. So you're not going to be responsible for getting all the way through the problem all on your lonesome. And even if you make a mistake somewhere, if you've seen the corrections that we've made up to that point, hopefully you can help me do the next step. Even if you didn't work through it correctly on your own. So that's okay. And if you make a mistake, it's no big deal, right? How many of us have done this before? Probably none of us. So it's okay if we make some mistakes right now. It's the first time trying it. I'm pretty lousy at something the first time I do it. It is okay. What's not okay is staying lousy at it, right? Hopefully we get better at things as we get a little bit of practice. So we'll start here with 28. In 5 minutes or so, we'll kind of stop and regroup, and I'll call on some random people to help us with the steps on how to get through this. So you all want to make sure you're trying so that you have some answers and aren't embarrassed because you're like, oh, yeah, I don't know what to do. You know, give you a chance to work on it a little bit. Yes. Yes. Alrighty here, folks. Let's take a pause at where we're at. And come back together. All right. Ava, can you tell me what's the first thing that we'd want to do here? I would not do that first. I think it's fine just the way it is. You could, it wouldn't be wrong to do that. Multiply both sides by x plus 3. Good. Yep. Now it's, again, to reiterate, not wrong to set it equal to zero, all equal to 0 at the start. Fine to do that. I don't know that you need to do it there. It's possible that this thing would come up to be like a linear thing and not a quadratic thing. So like, you don't know that in advance. It probably is going to be quadratic, but you know. Great. Okay. Let's see. Ruthie, tell me what I write next.
So once you do that, does it get to a quadratic?
Well, first thing I would do is rewrite it now, right? And what can I do with this? Okay, so Ruthie says go ahead and distribute that stuff through. And what can I do with that other piece?
Well, would it cancel out?
Uh-huh.
Okay.
And we're left with just 5. Great. Okay. Megan, what do I do next? Great. So it's got to equal 0 since it's quadratic to solve. Okay. Corey, what should I do here? Okay. What two things multiply to give me -5 and add to give me +3? Okay. So what should I do then? Great. What is it then? What is it then? Okay, so this is, again, that's fine, but this is something at this stage of the game we'd expect that we have memorized, right? Zach, do you remember? I see you mumbling. Okay, it's negative something, and there's a square root in it. B, and then plus or minus, and then what's underneath it? B squared. Yep. 2 over 2a. Yeah. So it's negative b plus or minus square root b squared minus 4ac all over 2a. Again, fine that we don't remember it right now. If you don't know it, memorize it. Like, for sure, get it on your equation sheet. Because it comes up frequently, right? All right. So we do that. We have 9 plus 20 over 2. 9 plus 20 is 29. Can I do anything more with that? No. Okay. Archlin, how do I finish this? What do I still need to do? So one more thing I still need to do. Katerina, do you remember? You look like you're trying to say something under your breath. Nope, because the square root of 29's prime, so there's nothing I can do with that. There's still something I need to do before I box this answer and call it fit quits. No, that's okay. Pat, do you remember?
Not really.
Okay, that's all right. Matt, do you remember? Before I can call this answer quits and done, there's one other thing I need to do. Do you remember? Yeah, we need to check. So how do I check this? Yeah, I just need to go back to the original and make sure that I don't get a 0 denominator. Now is negative 3 plus or minus the square root of 29 over 2? If I add that to 3, am I going to get 0? Definitely not, right? What do I need to add to 3 to get 0? Negative 3. Is that negative 3? No. So is this answer okay? Yes. So we're done. All right. Next one up. Give it a shot. We'll do the same thing. We'll just kind of call on some rando people as we go. If you didn't get called on yet, watch out because it's coming. Or if you didn't have a good answer yet, that's okay, but I might call on you again. Oh no. Batteries going flying all over the place. All right. Let's circle back here. So, Ryan, what's the first thing we tried to do here? Uh-huh. Great. So we start by factoring all the denominators. That works. Okay. Audrey, what next? Well, that's not the way we've been doing it. You could do it that way if you wanted to, but that's not what we've been doing. Okay. What was that same denominator you found?
I just like multiplied all the denominators. I don't know what I did.
Oh, that's going to be really bad if you multiplied all the denominators.
Yeah. I don't know.
Okay, that's okay. Katie, do you have?
I did the same thing.
Okay, it got real messy, right? Okay, Natalia? Yeah, that's the ticket right there. Okay, so that's good. Elise, when I multiply that both sides, what's the first fraction that I get? So we're talking about doing this times this and telling me what I get. Well, we're not going to multiply anything out yet. I'm just going to write the fraction down,
Oh.
is what I'm saying.
X times X times plus 1 times X times
Over, there you go. Great. The next fraction, Pat, can you tell me that?
3x, but 3x again, plus 3.
Let's just do it x plus 1
Oh, yeah.
over x plus 1. Let's not multiply anything out, right? Because we probably reducing to do. Nick, can you tell me the third one? Yep, so the third fraction. Okay. Great. Yeah, I'm going to write it in the factored form, but that's fine. You could write it that other way too. That's not wrong. Is everybody okay with how I got the three fractions? And why it's still equal to 0? So multiply it by 0. Okay. Archland, what can I reduce in the first fraction?
1 to X.
Great. And Audrey, what can I reduce in the second fraction? Great. And Katie, what can I reduce in the third fraction? And the x. So let's see. So now we have this stuff, right? Okay. Matt, what do I do next? And do something with that. Yeah, foiling it out, right? That's, I think, the term you're searching for. So I foiled it out. Then what do we do? Katerina? Combine like terms, I think is the phrase, yeah. Okay. This is looking kind of nice, right? Corey, what's up next? Okay, by doing what? Ooh. Ooh. What else could we try? Starts with an F. Factor. I came back to you because now it was factorable, right? So how do I factor x squared minus 5x? Just the greatest common factor, right? What's in common to both of them? Okay. So when I set each piece equal to 0, I get 0 and 5. All right, Lucas, am I done? What do I still have to do? Great. So when I plug them back in, does 0 work? It gives me a 0 denominator, correct? Is that good or bad? That's bad. Okay, so even though I got 1, that's one too many. That is an early announcement.
Before we come to the end of the day for our
This
prayer.
one works though.
Tomorrow, March 21st, is World Down Syndrome Day. Tradition on World Down Syndrome Day is to wear crazy socks. The theme of wearing odd socks was initiated to raise awareness. Over time, it's been promoted as lots of socks. The idea was created because chromosomes are shaped like socks, and people with Down syndrome have an extra chromosome. Many of us know somebody with Downs or have family members with Down. So tomorrow, if you would like to wear crazy socks, please do so in support of all of our friends and family members with Down syndrome. That's all for me, and in a moment we'll go on to prayer.
You couldn't have come in and done that at the same time as prayer? It's so close together. We're going to stop here.